Hello everybody and welcome back to this tutorial, and right now what we are going to do is we'll actually code a program that will help us to sniff the credentials from the FTP login. Now the FTP is really insecure. It sends the credentials, by which I mean username and password, in an unencrypted plain text, and all we have to do if someone is logging in from our local area network to the FTP is sniff for the packets and run our program, which will print out the username and the password. So let us see how we can do that. First of all, let us go to our Python programs, and before I do that, let me just enlarge this. Where is the enlarge? Okay, so it's here. Zoom in. Go to my local network programs, and let us nano ftp sniff.py. There, all I need to specify is first of all the line that we always need, user being Python, and we will use two libraries, one of them which we encountered before, which is the opt parse library, which we will use to parse our actual available options, which we will specify then to the user. And we also need to import this kp.all library, which will help us to actually sniff the packets and print the username and password from the packet. So let us import it. So import opt parse, and from kp.all import all, which we specify by this star right here. And for now on, what we want to do is first of all parse our settings, see what we will need in order to run this program. So what we will need is basically just to specify the usage of the program itself, which will just be running over the program, and specifying the interface on which you want to actually sniff. So basically if you type, let me just show you, if you just type ifconfig, you have multiple interfaces. In my case, I just have two, and one of them is the loopback interface, and I will specify this interface to be the interface on which I'm sniffing on. So you will most likely also have ETH0 if you're running on the actual Kali Linux machine. So let us go to the FTP sniff and see how our code will look like. We need to make, first of all, the main function, and in that main function, first of all, we want to parse the options. So we will use the usual thing, the parser, which will be equal to the opt parse dot option parser. This is something that we used before, so nothing really new for us. And in there, we want to specify the usage of the program for the actual user. So we can do it by this, specifying double quotes or single quotes and just printing usage of the program. So we close this, we can add in the new line. So backslash. We can use the backslash in order to specify the rest of the code in the new line, and all we have to add is another single quotes, and there we can specify the -e option to be the option for the actual interface. So we'll specify it like this, interface, and close it like this. So this will be the options that are going to be printed out to the user once they need to run the program, and all we need to do right now is actually add those options, which in our case is just the interface. So parser.add underscore option. And in the brackets, what we need to do is specify the dash or just -i for the interface. We will select that destination to be equal to the actual interface itself. And then in the next line, we can actually specify the type to be equal to the string, which we specify with this. Now, why I'm not explaining this is something that we did previously at the beginning of the course. So this you should already be familiar with this code right here. And the help option will be specifying, for example, specify interface to listen on. So you can specify something like this, and all we have to do right now is add our usual line, which will contain options and arguments, and that will be equal to the parser.parseArgs. So parser.parse underscore args. We open and close the brackets, and right now we actually need to check if the user has specified this option. So if it didn't specify the option, what we want to print is we want to print our usage of the program. If they did specify the option, we want to continue into running our FTP sniffer. So we can check that as always with the if options.interface, since that is the actual destination that we specified as an option, is equal. We need to specify double equal, since one equal, if you remember, will be only giving the actual value to the variable. So we need to specify double equal in order to check if the options.interface equals to none. If they do equal to none, what we want to actually print is print the parser.usage. And once we print that, we can exit the program, since user didn't specify it correctly and needs to run it once again. in the else statement, we want to specify that conf.iface will be equal to our options that we actually used in the parsing part. So this is the options, the only option actually, options.interface, which is specified right here. And what we want to try is try to sniff for the packets with this command. So we will try and accept. Accept can be actually stored in the keyboard interrupt. Since this is a sniffing program, we will sniff until the user actually wants to stop, which they can actually stop with just pressing Ctrl+C, which will close our program correctly. So keyboard interrupt. And then we will exit the program. In the try statements, we will actually run a function, which will be the sniffing function. So sniff, we want to sniff on the TCP port 21. Now the reason why we are sniffing on that port is because FTP is actually running on port 21. You can check that out on your Metasploitable, for example. If you open your Metasploitable and run an nmet scan or run any port scanner that we actually coded against the Metasploitable, you will notice that it is running FTP on port 21. And all the other machines and servers are also running the FTP on port 21. So we will use the filter to be equal TCP port 21. And the actual packet that will prompt back to the function that we didn't code yet will be equal to the FTP sniff function. So we will code it just like this. And then we will code this function in the next lecture. So for now on, what we did is we coded our main function, which contains the available options, or just one option in our case. It checks if those option is specified once running the program. Else we gives the options.interface to the conf.iface, which stands for interface. Then we try to sniff for the packets on the TCP port 21 and process the packets back to the FTP function, which we will code in the next tutorial. If the user wants to stop, they can specify the keyboard interrupt or basically Ctrl+C in order to close the program. So let us save this. And we will continue coding in the next lecture. Hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial where we will code our FTP sniff function, which is specified in our main function in the previous tutorial. So let us open our FTP sniffer with the nano ftpsniff.py. And let us see, we specified right here the function to be named FTP sniff, so we need to name it the same. So let us name it def FTP sniff. And in that, we need to specify the packet to be imported as an argument to this function. Now what we want to do is first of all get from the IP header the destination, so we can print to where the packet is going to. So we can print the IP address so that we as an attacker know to which machine can we attack once we sniff the actual username and actual password. So we can select that to be in the variable dest equals packet.getLayer. Now the get layer, we need to get the layer from the IP header and the field destination. So if you want to check it out, you can just open up Scapy, type ls the IP, and you will see the destination field in the IP header. After that, what we want to do is actually use the raw equals packet.printf. So make sure to specify the, oops, I'm missing R right here, so it's printf. And we need to print the raw packet, so we can just do that with the actual, let me just show you, we want to use the raw.load field, which we can specify between the %, so raw.load. You will see in just a second why we are specifying that once we actually get the user and the actual password. Now, in order to get the user and password, we need to use a library called RE, which will allow us to specify the actual way, or not the way, the actual pattern that we need to use in order to get the username and the password from this raw.load field, or basically now stored in the raw variable right here. The pattern I already checked before, and I will show you how it goes, so we don't actually waste time on that. But in order for you to understand this, you need to use the find all function. So what this will do is first of all type ref.findAll, and what this will do is it will take two arguments as an input. One of them will be the actual pattern from what you want to search for, and the other argument will be the variable or the packet from which you want to search for. So we want to actually specify raw as a second argument to this function, since we want to actually get the username from this raw variable right here. And what we want to get as a pattern is first of all open single quotes, and there you can specify open and close brackets. First of all, question mark. Let me just find where my question mark is. Then I, and outside of the brackets, you specify user and space, open and close brackets once again, and just type dot, and then star. So this is a pattern which will allow us to only print the username from this raw field right here. We also want to do the same for the password, which will be the same pattern. So if you go right here, and in our PSWD field, we want to, or not field, this is a variable, so don't confuse these two with any fields from the packets. These are not the fields, these are just variables that we are specifying. We want to actually do the same thing, so re equal dot find all, which will find all the actual patterns that are specified with this in this packet right here. So we want to do the same thing. In between the double quotes or the single quotes, we will just specify this pattern right here, and make sure to actually change the name right here, since it is not user anymore. We are looking for the actual pass, and also we want to get it from the raw field. So now that we actually specified the pattern in order to get the username and password from the FTP packet, wow, what we want to do is actually print to the screen the IP address from which the packets are coming to, or basically the IP address to which the username and password are being sent to, which is the target server or the server, any server running FTP. We want to print the username and to print the actual password. So let us see. Oops. We will check if user exists, so we can do that with the if user and then the two dots. We want to print, so print. We can do it like this in, oops, with a star right here. Detected FTP login to, and then we can specify the plus the string of the destination. Since the destination is our variable that stores the IP address of the server running FTP, we want to print that, and right below that we want to print the actual user. So under the plus we can use something like this. So user account, and then we add, now make sure to add a string from the user from the actual first element from the user. Now you might be asking, why are we specifying the first element? Well, this function right here will return a list from all the elements that are actually included in this pattern. And all we want to do is select the first element in order to get the username. Now most likely this user and PSWD fields will only contain one actual element, which will be the username and password, but they will be stored as a list. So this will be a list containing just one element. So even then, we need to specify the element to be in the actual brackets. So in the square brackets, we need to specify the element that we want to print. So same we need to do for the password, else if PSWD, if we actually find the password, we need to print with the plus password, and we can print plus string, and also use the PSWD and square brackets and 0 inside them. So we actually specify the first element from that list. So this should be about it for this program. If we coded everything successfully, all we want to do right now is actually call the main function down here, so we can actually run the program itself. And right now we can actually check to see if this will work. So let us save this, and before we actually do anything else, let us go and open up our Metasploitable, since the Metasploitable actually has the FTP server or FTP software running, and we can test this on that software. We will run this program, then in another terminal what we will do is we will actually try to connect to the FTP over FTP onto the Metasploitable, and we will see if this program will catch the username and password and the IP address to the actual target. So let us see if this will start soon. Let me just close this. Let me open up a second terminal while this is starting. So new window. Let us enlarge this, not like that. We want to enlarge it like this. To the side as well. Same with this program. So we can see everything well enough. Zoom this in, which will actually go over this terminal right now, but doesn't even matter. All we will do right here is we will actually perform the FTP connection. Right here, what we want to do, okay, so this is starting up. We want to run the program. Let me just see if it is an executable. It is not, so we want to make it an executable with chmod ftp sniff.py and run the ftp sniff.py. Now you can see nothing is being printed out except the usage. Okay, so yeah, I forgot about this. We need to specify the usage, so we need to specify -i and then the actual interface on which we want to actually sniff on. So ETH0, you specify -i and you specify ETH0 or any interface that you want to use. Right now our program is running, it is sniffing for the packets, and it is waiting in case we actually try to connect to the actual FTP server. So let us first of all see the username and password, so msfadmin and msfadmin. Let us check the IP address of our metasploitable. It is 192.168.1.4, and let us actually FTP to the metasploitable, which we can do with the 192.168.1.4. It will ask us for the name. Now, I have no idea. I believe it is msfadmin, and msfadmin as a password. We can see login successful, but we can also see in our second terminal that we received detected FTP login to this IP address, user account msfadmin, and password msfadmin. So we successfully sniffed the username and password. So all we have to do is just fix this part right here. We will just strip the /r and /n. So let us do that right away. Nano ftp sniff.py. And all we want to change is actually printing string from the user and then .strip. We want to strip from the character /r. And we want to strip from the character whoops, we open the single quotes, /n. We want to do the same right here, so .strip from the character /r, close the brackets, and do once again .strip from the character /n. Close this, close the brackets, save this right here. Run the ftp sniff.py once again. Let us close this so we can check exit. Okay, so we need to specify the interface. I always forget that. The interface ETH0. We let this run and let us try to connect once again. So ftp sniff, msfadmin, enter, and msfadmin. Now for some reason it is still printing out the /r and /n, but it doesn't really matter. We know that those are the characters that come from the Python and not the actual characters from the username and password. What we the more important thing is that we are able to actually sniff the username and password and to also sniff the IP address from which the login is coming to. Now what you want to do is actually run this with the ARP spoofer while forwarding the packets. Now we coded ARP spoofer before, so you should already be familiar with that, and you will be able to actually sniff the username and passwords from any account on the local network. So for example, if you're in a cafe and someone wants to log into the FTP server somewhere, and you can sniff their username and password easily. So that will be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial what we will do is we will see how we can actually sniff the usernames and passwords from any HTTP website that the target actually opens. Now make sure to actually, while running this program that we will code right now, make sure to have the ARP spoofer and the the packet forwarding enabled in order to get this program to work. So let us see how we can do that. First of all, what we want to do is go to our Python programs and go to our local network programs. There we can actually make a sniffer. So since this program will sniff any username and any password on the HTTP websites, you will call it sniffer.py, so nanosniffer.py. We start off with a usual line, which is user bin Python. And after that, we want to import two libraries. Now, they are the same libraries, but they are specified in the different order. So let me just show you. Import scapy.all as scapy, which is something that we encountered before. And from scapy_http, import http. So if you just save this, I will show you how you can install scapy_http, since it really doesn't come in the Cal Linux, since I had to install it like 10 minutes ago or something like that. You need to type pip install scapy_http, and you let this run, and what this will do is it will collect the library for you, and then after that you will be able to actually run the functions from this library. As you can see, for me the requirements is already satisfied, so all I have to do is actually code the program from now on. So go to my sniffer.py, we imported the library, and let us use a function from scapy called sniff. In that function, what I will specify is the actual interface, which in my case will be once again ETH0. And all I want to do is actually code this function upwards. So we will code it and we will name it the same. So def sniff. It will take an input, as you can see, the input of the interface. And with that interface, we will use the scapy sniff function, which will be scapy.sniff. And then iFace equals to the interface. We will not store any we will not store anything basically, and we will process the packets to the function called process_packets. And basically these are the three arguments that we specified right here. We selected the interface to be equal to the argument that we parsed to the actual function. We said store equals to false, which means it doesn't store packets in the memory. And basically PRNBack is the callback function that we will use in order to process our packets. So all we are left to do is actually call the process packets function. Let us go right here. Def process_packets. In that function, we will need to paste the argument of the packet itself. And what we want to check first is, for example, if you have any knowledge in the actual websites, you know that everything is sent over HTTP requests and responses, as well as the usernames and passwords. So what we need to check is since we imported this KP_HTTP, we want to actually check if our packet we are processing has the layer HTTP. Most likely, we want to actually send the layer to be set the layer to be HTTP request, since in the request, we're actually requesting to log into some page. Then the response, the server will send back the response saying either we log in successfully or we didn't. So what we want to actually specify right here is three things, the same as in our FTP sniffer. What we want to specify is the actual URL from which the username and password is coming to. So basically, if someone tries to log into the Facebook, we need to also print out that the login username and password is being tried on that website, which will be facebook.com. Since if we just print the usernames and passwords, it doesn't mean anything to us since we don't really know where to use those usernames and passwords once we sniff them. So we need to check if packet has layer, and the layer will be called http.http capital and then capital R and then request. So HTTP request. This will perform the function of actually checking if this layer exists in our packet. And what we want to do is actually select the HTTP request packet to be equal, the URL to be equal to http request.host. So the host is the target that the user is trying to send the password and the username to. So we want to sniff that as well with the URL equals. URL is the variable that we will specify the host to be in. So packet from the http.http request. And we want to take the field called host field. We also want to take the path, since we actually want to get the path to the page where they are logging in. For example, some pages can have multiple login forms, and the multiple login forms can be stored on different paths. So we will also want to get the path, which we can do with the packet and open and close brackets, http.http request. And we want to get the path as well. So the path, once we do that, basically we can print the URL. So print it just like this, print URL. And all we want to do is now check if our Scapy or our packet has the layer scapy.raw. Now, you might remember that layer from before. Once we actually send the self-drafted TCP packets with the load field containing our message to the target, once we actually run our SynFlutter, from there you should know the layer, and in this case that layer will contain any username and password that the target might specify. So let's see how we can do that. We can check that if packet.hasLayer scapy.raw, and from that raw layer, since the raw layer only has one field, and let me show you in case you forgot, if you open Scapy and you just type ls in the brackets raw, you can see that the raw layer only has the load field, which will contain the message. So let us exit this, and in our case it will contain the username and password. So open this up where we stopped. Let me just go back to right here, and then we press the .load for the actual username and password being stored there. We want to check for the actual keywords. Now the keywords are basically something that we are searching for in this raw layer. So we can specify them right here. Or we can just go down here, it doesn't even matter. We can just select the words to be equal to the open and closed square brackets. And there we can specify what we are searching for. We can search for password, username, basically anything that you might actually encounter in that field. Capital user and so on, it doesn't even matter. We'll just specify this for now on. Let us also add the capital password. This is our words list, which is containing the words that we're actually expecting the raw field to have once someone tries to log in somewhere. So all we have to do right now is actually iterate over these words and check if any of those words is in our field right here. So let's first of all add the 2 dots right here. And all we want to do right now is actually select, or pardon me, we don't want to actually select the dot load right here. We only want to select scapy.raw, and we want to select the load to be equal to the packet in the square bracket scapy.raw, and then dot load. Since we don't really want to specify all of this always, so we just put that in one variable so we can actually navigate more easily. And then for some variable I in words, which is our list that we created previously, we want to check if I is in string from our load variable. Make sure to specify string right here, otherwise this will not work. Specify 2 dots, and we want to print load. So let us actually check out what we just coded right here. If we first of all check if this packet has layer raw, which will contain usernames and passwords. If it does, we select the load field from the raw packet, from the raw layer to be stored in our load variable, and then we iterate over this words list right here. In case any of those words is in the string of our load variable, we will print the load. And then after that we can actually break from this actual loop. Let me just go right here, since we sniff for the packets. So all you can do is first of all check if this is running. So chmod sniffer.py, run the sniffer. As we can see, everything works well enough. And all we have to do is actually just find the HTTP website on which we can sniff. So we can go to our actual fake Facebook page. Let me just see. Let's open it like this, so we can see everything good enough. And here, let's specify, for example, this and some random letters. We click here on login. For some reason, it didn't catch it. Let us try another page. So let us try, for example, my router, but I'm not really sure it will work on router, but let's give it a try. Why not? So let's see, we got an error, so that is actually good. So we know something is wrong. I mean, it's not good, but we know there is some error somewhere. So first of all, instance method object has not attribute get item. So let's check the line where the actual error is. If packet has layer scapy.raw, so let me just go to my sniffer in order to see whether that was a mistake because we tried to connect to the router or something else. It could be just because of the router, so nothing really to worry about. If packet has layer, okay, so we actually need to specify this in the actual normal brackets. I just noticed that we specified it in the square brackets, which we really shouldn't do that. So make sure to change that. We need to make sure that here is specified if packet.has layer, and in the normal brackets, scapy.raw. And then also, let me just check down here. This should be like this, so this is good. This didn't work since has layer is a function, and a function can't really have an argument specified in the square brackets. So let me save this. Run the sniffer once again. Let me cancel this and reload the page. Okay, I reload the page, we get the IP address. I type something randomly, click here OK. But we can't seem to really get the username and password. But once again, that could be just because of the actual router and not because of the program itself. So let us try something else. It doesn't seem to work, but this actually redirects us to the HTTPS, so that could be the problem as well. Now, I don't really know any HTTP website that we can test this on. Basically, if you know one, you can just try this and test it and check out if this will work. Now, I believe it will work, even though I don't have anything to test it on. Let me just enlarge this and see if there is any other problem in the code. So nanosniffer.py. Everything should be correct. We have our words list over which we iterate. It prints the URL once it sees that we actually get the HTTP website. It checks if this packet has this layer right here. Then it prints the load. So for me, if you ask me, this should actually work on an HTTP website. Don't really see any error, nor we get any error while trying to run the program. But I don't really have any HTTP website to test on, as I said. So if you have, make sure to test it and feel free to comment whether you got it to work or you didn't, so we can actually update this video and get it to work. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye!